Okay, let's look at example 2.3. 2.3 is an example of a bolt or an eyelet of some sort with multiple forces on it. And what we're going to do is we're going to break these forces into their x and y uh, components of the force, and then we're going to add them up because we want to say what is the equivalent if we were to replace all four of these forces with a single force. What is the equivalent? Okay, so let's look at this. Let's start with force one. So here's force one right here. Okay, so how do we do this? We're going to come in here and let's draw force one. There's force one, and this is 150 newtons at 30 degrees. Well, this is going to have an x component of it going to here and a y component of it going there. This is F1, so this is F1 in the y direction, and this is F1 in the x direction. So F1 F1 in the y direction is what? It's uh, F sine of theta, so it's equal to 150 times sine of 30, so it's equal to 75. So let's put that here, F1, this is 75 in this portion. And F1 in the x direction is F cosine of theta, so it's what, 150 times cosine of 30, so F1 in the x direction is going to be 129.9. So we have 129.9. So pretty straightforward. Now let's look at the second one. The second force is coming off at this angle right here. Well, that's maybe a little extreme, but you get the idea, right? With this angle here being 20 degrees. Okay, so the y component is going to be clearly here, and the x component is going to be in that direction. Now here's one of those cases where we're going to say f1y is equal to what? It's equal to this is f2, f2 times the sine or cosine. Well, generally speaking, when we say y, we talk about the sine, but in this case, it's going to be cosine of 20. So why is that? Well, because if you had defined the angle from here over to there, then it would be f2 sine. But we're given this angle right here, and so you just have to look at the triangle and do the trig. And so therefore, f2y is equal to 80 times cosine of 20. So that ends up being equal to 75.2. So let's put that over here. 75.2. See if I clean up that 7 a little bit. Okay, now f2x is going to be f2 sine of 20. So this is going to be 27.4. But you'll notice this is in the negative direction, right? So it's a minus 27.4. Well, does that make sense? Yeah, it does. Minus 27.4. Again, if you were to define the angle, this whole angle right here, then you would get that automatically with the f2 cosine theta. But we're using the trig and doing it from there. Okay, the third force is straight down. Here's this force, well, that's supposed to be straight, don't tell anyone. And this is 110 newtons. Okay, so F3 in the x is what? Well, it's 0. You can just see that it's 0. And F3 in the y is the full minus 110 because it's going down. So let's put that in here. So this is going to be 0 and minus 110. And then last one is F4. So F4 has this force coming off here at 100 newtons. And this is at some angle 15 degrees. So this, again, the x component is going to be here. The y component is there. So therefore, f4x is going to be 100 cosine of 15 degrees. So f4x is going to be 96.6. So let's put that in over here. 96.6. And f4y is going to be 100 times sine of 15. So that's going to end up being 25.9. But again, it's in the downward direction. And again, if you had defined the angle from here all the way to there, it would have taken care of the sine automatically. But we haven't done that, and we're just using common sense on here. So we're going to put in minus 25.9. So how do we figure out what this r is, this resultant value? Well, you simply add up all the x's on all the y's. So in this case, you add up all these, and your x component is 199.1, and your y component is 14.3. So therefore, this whole thing can be expressed as one single force coming off here, going 199.1 in the positive x direction, going in that direction, and a small little portion of it going in the positive y direction of 14.3 for a resultant that passes up here. Now what is that angle? Well, you can figure out that angle so that tangent of theta is opposite over adjacent, right? So 14.3 over 199.1. So therefore theta is equal to 4.1 degrees. So you could either say that, I'm personally inclined to say that the x and y component of it are this, that your r is equal to 199.1 in the I direction, that's an arrow, sorry, plus 14.3 in the j direction. Or you can say r is equal to, there's a vector, the square root of 199.1 squared plus 14.1 squared, all that at an angle of 4.1 degrees.